Alrighty. Good morning or afternoon, wherever you're tuning in from. Oh, this coffee is amazing. I'm ready. Okay. We are working on day 11, Advent of Code. Okay, Dumbo Octopus. You enter a large cavern full of rare bioluminescent Dumbo octopuses. Octopuses? Should be octopi, I think. They seem to not like the Christmas lights on your submarine, so you turn them off for now. There are 100 octopuses arranged neatly in a 10 by 10 grid. Each octopus slowly gains energy over time and flashes brightly for a moment when its energy is full. Although your lights are off, maybe you could navigate through the cave without disturbing the octopuses if you could predict when the flashes of light will happen. Each octopus has an energy level. Your submarine can remotely measure the energy of each octopus, your puzzle input. For example, we have this. Okay, copy that. The energy level of each octopus is a value between 0 and 9. Here, the top left octopus has an energy level of 5. The bottom right has an energy level of 6. You can model the energy levels in flashes of light in steps. During a single step, the following occurs. First, the energy level of each octopus increases by 1. Then any octopus with an energy level greater than 9 flashes. This increases the energy level of all adjacent octopuses by 1, including octopuses that are diagonally adjacent. This causes an octopus to have an energy level greater than 9. It also flashes, so in the same step. This process continues as long as new octopuses keep having their energy level increase beyond 9. An octopus can only flash at most once per step. Okay, so I guess that's to prevent infinite recursion, but do we need to keep track of that, or does that happen naturally? Finally, an octopus that flashed during this step has its energy level set to 0, so it has used all of its energy to flash. Adjacent flashes can also cause an octopus to flash on a step, even if it begins that step with very little energy. Consider the middle octopus with 1 energy in this situation. All of its neighbors flash, so then this one ends up flashing. Okay, this is actually a good test step. So, okay, and then there's a larger example. Oh, we've got lots of test steps. Okay, so after 10 steps, there's been a total of 204 flashes, so we need to keep track of how many flashes there are. Fast forwarding here is the same configuration every 10 steps, so then we can step a certain amount of times. Yeah, so I would like to be able to run in each one of these and test that they are correct. How many total flashes are there after 100 steps? Okay. Okay, cool. Let's go ahead and get started. I have made a couple of additions to my Vim setup. Ooh, wow. Let's try that again. Uh-oh. That's not good. Can I just launch it by itself? Wow, okay. This is not good. Well, I guess I'm going to do this in terminal Vim then. Oops. Muscle memory. Let's do, wow, I don't know what happened. I was just using this yesterday. Okay. Most of what I have should work in terminal Vim as well. Okay, so I was messing around with this structure for day 11, but I haven't actually done any of the code yet. Let's do day 11 / yeah. Okay. Day 11.swift. Okay. Enum day 11 static func run. I got rid of auto pairs, which is why in this example, if I do that, normally it would have done this for me, which usually I like. but it was conflicting with some other stuff, which I didn't like. And so I'm not quite sure how to resolve that. Maybe I will switch to a different plugin that can do that. Auto pairs is gone, but what I added was LSP config and mvim compy. I don't know how to pronounce this. Compe. And what that does is if I have a let's open up this, and we're going to add xc run toolchain swift source kit lsp. And I think it's already running, actually. Yeah, it's already running, perhaps. Well, I don't know if it's because Xcode is running. Let me quit Xcode and see. Yeah, okay, so this, let's kill that and 50549. Okay, so we're going to run source-kit LSP, and this comes with your Xcode implementation or installation. You have to make sure you're using the same version of the Swift that you want to run. But what this is going to do is it's going to scan this folder and give me code completion and diagnostic information while I'm in Vim. So for instance, if I want to say self.foo, and I save it, well, this is syntactic doing that. Let's do... This is working a little bit different than we did see it a second ago, where it says top level expressions are not allowed or whatever when I was doing this earlier. Let me relaunch Vim just to see if that has anything to do. Okay, here we go. Yeah. So now we have code completion as part of our Vim setup. And I've made some keyboard commands or remaps or whatever that will let me use the tab key to do this. And if I want to expand one of these, I would like to use enter, but I don't think that works. So anyway, this is kind of a work in progress. So we'll see how it works for this. It would be kind of nice. Okay, so we had some test input that I wanted to run. So let's just say input equals, not that. Let's see. We had this input. Okay. And then we want to model this essentially as a grid. And so I'm going to create a grid. And I feel like this is stuff that we've done more than one time. So I kind of want to model this as a grid where like what the things in the grid are whatever we want them to be. In this case, they'll be integers. But if we wanted to model this as an individual struct itself that had the energy level and whether it flashed the step, we could do that. But for now, maybe just a grid of values. And you can, let's see, you can initialize this with its values as a 2D array of those values. But as we saw in a previous stream, we could also model this as a, like, I'm not sure if our internal state is going to be like that. So let's say private var values is value, like that. Or I want to actually, let's call it data. And then we'll say data values like that. Okay, I think I'll start with this, but we may decide we want a one-dimensional array instead. I don't really know. Okay. So let's see if we can, we could actually have an extension on grid where the value is an int, and then have a static func parse, which takes that input string and returns self. And it either needs to throw an error if it can't parse, or fatal error, or return nil, I guess. So I suppose we could always return an empty grid. Okay, so what we're going to do here is we are going to take our input, split it into lines, and then for each line we want to map that to its characters, and then map those to integers. So we can take an array of $0. $0 is the string for this line. Array will give me the array of characters, and I want to map each one of those to int.init. And I'm 90% sure I have that needs to be compact map. I'm 90% sure I have that initializer. Maybe I don't. Okay, so this gives me my my data, and then I can return a grid with that data. Okay, let's go over to util.swift, and I thought I don't. Okay, let's add another extension on string that lets me create it from a character. And I feel like because these two things are identical, couldn't I initialize with anything that is expressible by string literal? I think I could do that. Does that work? No. Okay, so can I do that? I can't convert that to a string. Okay, here's another thing I did. I want to look up the documentation for this word that I'm sitting on, and Shift K is kind of the default Vim shortcut for like finding documentation. But I have that searching dash in Swift. So in a Swift file, it will, I'll show that real quick. If we go down to, where is it? Here it is. Okay. So I've got a couple of things. Dash open, we'll just open dash with the current word, but this is going to search every kind of language and doc set that I have. But then I also create a command called dash swift, which will open with the Apple : prefix, and that will search the Apple docs. And I want to use, when I'm mapping Shift K in just any file, I just want to open generically. But if my file type is Swift, this will remap that same command to do dash swift. So now I get the Apple prefix on there. And so now that allows me to go over here and say, okay, what are the docs for this? I just hit Shift K and it does a search for it. And then I have to hit enter, but that's it. Okay, so string and static string are the only ones that conform to that. What about character? Conforms to, custom string convertible. That's what I want, I think. Because then I can just do description, I think. If the past instance conforms to it, that's a screen describing integer and print, use the custom description prod. Okay, yeah. Okay, so we're going to do that. That's what I want. Custom string convertible S. And now that means I can take the, oops, delete surrounding. Come on. int s.description. Okay, so let's do a build and see if we haven't broken anything. So we're building everything, including previous days examples. So so we can see that that actually works now, and character conforms to this. So now if I go back to here, let's see, why isn't this working? Is it just stale? It is. Okay. Here's another thing. Occasionally, you need to go like punch source-kit LSP and get it to reload. So sometimes that can bite you. But I'm already liking this getting code completion and being able to look up documentation quickly. Okay, so now we've got a grid that we can parse, and that grid values are generic. So I should be able to say let grid is equal to, and I need to tell it that this grid events equals to .parse input. And then I want to grid.print. Actually, I think I want to be able to get the string. So I want to say print grid.description maybe. Yeah, I'm just going to say print grid. I'm going to extend grid and make it conform to custom string convertible, which means we need this string property for this. And here we can say for row in values or data, and we need to get, actually, no, I can map this whole thing. So let's do data.map row in, row.map column in. We just want each column, we just need to wrap it in a string. Let's do that. And so now I've got an array of strings. These should be joined these should just be joined together. And these should be joined by a new line. Okay. Row is an array of ints. Yeah, it's an array of ints. Oh, it doesn't know that I can do this, because it doesn't know that these are strings or ints. So I wonder if I need to say where value is an int. But it would be nice if I knew, like, that any type that could be converted to a string. I could say where the value is custom string convertible, and I'm pretty sure that would do it. And then I could do $0.description. Okay. And then joined separator is what I want, I guess. Okay, there we go. So now I should be able to say print grid and see what it does. Okay, Swift run. We're still running day 10. So let's go to main.swift. Comment that out. Build. Go back to where we were. Run. Okay, so that's not printing my description. For some reason. Requires a type of int and custom string convertible to be, really? I could have sworn that int would be custom string convertible. Let's look at the documentation and see what it conforms to. Interesting. Okay. Then in this case, I'm just going to say where the value's int. We'll make it work for others when we get there. So that'll be string $0. So it's essentially I need to be able to provide some sort of function that says, give me the string representation of a given row, and then this would work. Or of a given value, right? And then I could have defaults for other types as well. Okay, let's build, let's run it, and now we get our grid. Okay, so this grid looks good. What I want to do now is have some sort of simulation. Energy level simulation. And this is going to take in our initial grid. Let's see, private var grid. Init with the grid, initial grid is a grid of int. Okay, and then I want to a mutating func tick and have how many steps that we want to run, which will default to 1. And the idea here is that every time we call tick, it's going to update this grid to the new grid that contains all those mutations. And I kind of don't want to do this here. I think that maybe this is just tick 1 step. And then if we want to loop, we can do that externally. Okay, so step 1 was to take all of the items and add 1 to it. And the way I am thinking about this is like this. If we want to grab 1 for every item in the grid, it's kind of like we'll have a new grid is our grid, and I want to map that to like $0 plus 1, and that will just like map every value. And that means we would just have to implement this method. It means to self.grid equals new grid. Okay, let's make that map function work. Okay, so extension grid func map. This needs to give us some sort of other value, u, which is going to return a grid of u. And then we need to provide a function that takes our value and returns a u. So now I can take data.map, row in, row.map, function, and then wrap that whole thing in a grid initializer. Grid of u. Yeah. So now we have an easy way of incrementing all of the items by 1 in the array. So let's run this. We'll print this grid, then we'll print a separator, and then we'll print. Actually, we need the simulation. Sim equals energy level simulation, passing in grid int. That's actually yeah, we can just say parse input here. And now we can say print sim.grid. This is private. I just want to make it private set, so you can't set it from the outside, but I could read it. Sim.grid. Then we'll say sim.tick, which means that I need to make this a var, and then print it again. I'm finding that the syntactic isn't as helpful because notice we get the error right here. And if I save it, I have this giant window that I have to like actually quit out of to move my... I don't know how to get out of this quick fix window without :Q, but then it stays up there because it's... I'm going to turn syntactic off for the moment. Leader ST will toggle it on or off. I wonder if I can just say check on W equals 0 so that it just doesn't run when I don't want it to. Okay, so I can turn it off, right? Okay, I think I'm gonna leave it like that for now. And then if I want to, I can do leader ST to get a, to bring it up, and then leader ST to turn it off again. Because having a quick fix window of all your compile errors is great if you're, you know, making a refactoring and you're touching lots of files or whatever. Okay, let's add initial grid there. We're gonna build. What did I miss there? Nothing. Okay, we're gonna run. Okay, after one step, we've got 2s and 10s, which obviously can't work, but we are mutating everything by 1. So now let's take this, and I want to flash each. I want to flash each neighbor, or sorry, flash each item that's greater than or equal to 10. So at this point, I believe we're just going to have to iterate over this. So we could say for row in 0 to grid dot row count. Let's do that. Or we could call it height. So that's going to be data.count. Grid.height. Then for call in 0 to row.count. Okay, so now we're looping over each one. And this is going to allow us to say, okay, give me the item at that value. So I could say subscript for row int call int gives me a value. Like this. And I probably also need the setter. So this would be values of row call equals new value. Sorry, that's data. Okay. I always forget how subscript syntax works. That looks correct, actually. Expected expression. Oh, do I? Yeah, I don't pass a new value. I just get a new value. Okay, so now we've got a way to subscript this grid. And now I can say if the value of this grid at row call is greater than 9, then we need to flash, right? And flash means we need to get all of its neighbors. And increment them also, but then they also might flash. So we have this whole step of mapping everything probably doesn't make sense because we're going to have to do it individually anyway. So it's going to be like take the item at grid row and call and add 1 to it. This is at grid for that row. Count, yes. Okay. Yeah, you see what I mean? Like, I need to... how do I get SourceKit to figure this out? Oh, my subscript... yeah, I can't get a subscript like this. I think I'm just going to say width here. Just width is data.first.counter 0. So if you have no data, you get nothing. Or if empty array or whatever. And now this can be grid.width. Do I not? Oh, okay. Okay. If so, we increment. If it's greater than 9, this whole increment is going to actually have to be nested in a function. Let's call this increment. We're going to pass in the row and the column and the grid, I guess. In out in grid of int. So the reason I want to do that is so we can move all of this in here. And now I can say inc row call in grid, in new grid, because we want to mutate the new grid. Let's do this. New grid equals grid. So hopefully we can keep, we keep a copy of our data, we mutate it over and over and over again, and we assign it at the very end. So so that allows us to check. And for each one that is flashing, we need to set it to 0 and then increment all of its neighbors. So this is going to be 0. And then I need to figure out what all the neighbors of this cell are. And because this is going to happen over and over and over again, I think I want to compute the neighbors for each one. So I can just say for neighbor in neighbors for row and column. Something like this. And then increment those two. Row. Yeah, I'm going to do that. Okay, so let's create a private func neighbors for row int call int returns an array of tuples of int. So it's going to be a row and column. Okay, attribute private can only be used in a what? Let's see. Let's make this like that. Okay. Can only be used. Oh, yeah. I'm not in top level. So let's do this. And I actually want to pre-compute neighbors. Because because I don't want to call this function over and over and over again and keep recomputing the same data. So here we'll have a private var neighbor cache, whose key will be this tuple int, and whose value will be an array of int. And I'm already realizing that I need a type here. Yeah, because it doesn't conform to protocol hashable. Okay. We already have a coordinate type in a few different places. So let's take this one and make it public. Just like we have this grid, having coordinates will be helpful. Okay, so now we do already have a coordinate somewhere else, not in height map. Day 5 has coordinates. Yeah. Day 5 has coordinates. Again, it's the same idea. It just needs to be, we just need this parse method. Let's go copy that. It has that debug string thing, which was slightly different. So I don't know which one we want. Let's just get rid of that. We'll only use this style. And then we will delete this. And that will probably make, coordinate has no member X and Y. So X is column and Y is row. Okay, we've got a few more errors here. So this is an error, a case where syntactic would be helpful, because now I can say, oh, okay, let's go straight to this one. I need this to have row and column. Row Y, column X. Okay. Coordinate has no member parse. It should once everything else gets figured out. Here, a line segment, we're trying to parse. Again, I think that'll figure it out. Debug description, this will be just description. X becomes column. Y becomes row. Column. Row. And one more. This is row. So this is kind of annoying, but let's move this. So VT closing bracket X to copy that or cut it. Find, oh, didn't go back. Find opening paren. Put this there, comma. There we go. Then we can change this to row. Change that to column. Okay, we are closer. Okay, so now our neighbor cache is going to be from one coordinate to a set of other coordinates, maybe. And this one now needs row and column, so that would be 1 call parts 0. Okay. So now neighbors, this is going to give me a coordinate. And this is going to return to me a set of other coordinates. And I suppose we could just do this right away. So we would say if let existing, or if let cached neighbors equals neighbor cache. Oh, that was weird. Neighbor cache for this coordinate, then we can just return cached neighbors. Something going on there, which is a little bit weird. Okay, otherwise we need to compute them. So we will, we could do this in a few different ways. Because one thing I was thinking is from -1 to 1, this is our range of rows. And this is also the range of calls offset from those. And I basically need every combination of these pairs except for the center and except for anything that's negative. I'm pretty sure Swift Algorithms has a solution for this permutations. Permutations of count or combinations. Unique permutations. Let's see. Okay. So if we have 10, 20, 30 numbers.permutations, permutations of count 2, yeah, I think I could just take the range and do permutations of count 2 because this gives me, does it ever give me 10 and 10? It doesn't. So I think to generate only unique permutations, 20, 10, and 10, 10, 20, 10. Okay. What about the combinations? So this is in a single collection. Combining collections. Product. Winter, spring, summer, fall, product. Okay, yeah, that's cool. Yeah, I like this. Okay, so we're going to say, let's see, so that's for row offset, column offset, in rows.product. We'll have to add import algorithms. Rows.product calls. And then we'll say where row offset is greater than 0 and row offset is less than the grid's width or height. I need to figure that out. I want to be able to hit enter here, but it just keeps putting null. I'm not quite sure why. Okay, so this gives me our where clause, our row offset is correct, and our column offset is greater than 0, and column offset is less than grid.width. Oh wait, I can't do that here. I need to actually produce the values first. Okay. Okay, so the only one we don't want then, where we want this excluding 0 and 0. So I'm just going to do that inside the loop. So if row offset equals column offset. I can't do that, can I? But they all equal 0. That's kind of cool. So this means we just need to skip. Okay, closed range int contains no member product. Oh, it's product rows calls. Okay, this would be cool. I thought maybe it was going to let me do this. So if these two are the same and row offset equals 0, I don't really like the way that reads. So if row offset is 0 and column, let's do it like this. Let's create a tuple. If row offset call offset equals 0, 0. That reads a lot better. So we need to skip ourselves. And then we will take the row to be our row, coordinate.row plus row offset. And we'll do the same thing for column. And then if let's create a valid range is 0 up to, but not including the grid's width. Oh wait, if we know it's a 10 by 10, but I don't want to hard code that into this. I don't want to like codify that. So that'll be valid column range will be that. And this will be valid row range will be up to grid.height. And then we can say if valid column range includes C and valid row range includes R, then this is part of our set. Okay. Is that correct? Yeah. Neighbors.add should figure this out. Come on. Coordinate.init. Row and column. Oh, it's not add. Insert? Yes. Okay. Now that we have our neighbors, we want to cache them so that next time we ask for them, they will be already there. So let's take cached neighbors for this coordinate equals our neighbors. Our neighbor cache. Self is immutable, so this is a mutating private mutating func neighbors. Extra argument and call. Yeah, so I need to now turn these into coordinates. And it kind of means, like now it seems to me that iterating like this doesn't really make sense anymore if I could tell the grid to just give me all the coordinates. But for now, let's just take a baby step and say coordinate is a coordinate for row, call. We will pass in a single coordinate to increment that coordinate in the new grid. And let's update this to take that coordinate. Okay. Now I want to teach our grid how to subscript for coordinates. It should be the exact same thing here, but this time we pass in a coordinate. And then this is coordinate.row, coordinate.column. Okay. Okay. Getting a little bit closer. So let's take the coordinate for each one of these. Change till closing coordinate. Now I can, now I can do that. And neighbors are going to give me the coordinate as well, or accept the coordinate. Return neighbors here. Okay, so now for each neighbor in the neighbors, we are going to call inc on the neighbor, which again will recurse in, this needs to be called grid. We need to be careful actually. Right here, we're mutating the self grid. We want to only modify the one inside this expression. Yeah, a little, it would be nice if the compiler said, hey, you accept this argument, but you never use it. That would be a good warning to have. Okay, I think that this might work. Let's run our builds. We're still... Actually, I'm not quite sure what is happening there. Let me open up this. I'm going to do Swift build because I got Swift clean. Can I do that? Clean build. Oh my God. Swift help build. Let's just remove the build directory and run Swift build again, because there was some sort of warning or error that I missed, and then it didn't tell me it again. Okay. We've got some warnings. Trailing closure in this context. So these are all things that are not part of our current thing. So I will try to clean this up later. I don't want to change focus at the moment. Okay, so back over in Vim, we do a build, we do a run, and after a single tick, is that correct? Doesn't seem like it. After step one. Okay, so something happened from here to here. Let me do this so we can actually see it. Okay, 3, 4, 5, 4, 3 on the top. But something happened on the inner part of it that isn't correct. I do kind of want to check to see if the neighbor calculation is correct. But it seems like it, the top row and the bottom row being correct and all of the edges being correct seem to indicate that that's true. After singles, I think maybe I'm running into the problem of it can only flash once. So what I'm wondering is this one flashes, right? And that causes its neighbors to flash, but they've already flashed that step. Yeah, an octopus can only flash at most once per step. So does that mean it stays 0 until the next round? So here, when we are ticking, when we are incrementing rather, we increment it +1 and then we check to see if it should flash. So we have no way of knowing that this, like, if this one starts at 0, that's fine. If it's the first time through this loop. But otherwise we could say, oh, if you're 0, it just stay 0 for this step. So maybe, like, I don't really like this, but like, is flash bool false? Okay, so if we pass that here, not here, we're incrementing is flash true, right? Because we are flashing. I think I need to increment first, then process the flashes. Increment the whole grid first, then process flashes. Does that change my results? I mean, in this case, this one would cause this to go to 10, and then when it visits and cause it to flash before it incremented by 1 the first time, and then it would increment by 1 after that. So yeah, I think I need to save the flashes as a set of coordinates, or probably an array of coordinates, so I can do these in order. And then anything that, so we get the coordinate, we increment it, now I kind of want to go back to my map to $0 +1, increment first, then loop over checking flashes. So if the grid at this coordinate is greater than 9, then we need to flash this row. And then we wouldn't flash any neighbors that are 0 because they've already flashed at this point. So let's call this flash now. But then I still need to check. Let's call this check flash. Because I still need to have the check. I just don't want to increment here. Or do I? I don't, because I want to increment first up front. Then I want to check the flash for that coordinate. And then increment the neighbors also. So this would be grid for neighbor plus equals 1. And then check flash on neighbor in grid. And then I don't think we need the is flash anymore. Okay. So then I don't need that either. So we increment first, then we have a function to check flashes. We go through every single one of our coordinates. If the coordinate is greater than 9, then we flash or check we just check for flashes in that coordinate for every single element. That will check to see if it's greater than 9. If so, it will flash by setting this one to 0. And then if the neighbor is already 0, if grid for that neighbor is 0, then we've already flashed, skip it. Continue. Otherwise, we'll increment it by 1, then check to see if that one is flashing. Okay. Let's see. Let's build. Let's run and see what we get now. That looks correct. Let's run it after 2 steps. I think we had after 1 step, after 2 steps. So let's grab another one. After 1 step. After 2 steps. Okay. After 2 steps, we have 4, 6, 5, 4, 5, 1, 1, 1, 1, 5, 6, 1, 1, 6. Yep. Okay. I think we are ready to put our input into this. Let's go grab resources, day11.test. Let's grab our guy here. And let's do a sanity check on our input. So here, this input is going to be read file day11.test. Then after, let's see, we have examples for step 1 and step 2. Let's just run those. After step 1, 6, 9, 5, 4, 2, 5, 4, 3, 3, 4. And the last line, 6, 2, 3, 7. This looks correct. I think that's correct. And then after 2 steps, 8, 8, 0, 7, 4, 6, 7, 6, 5, 5, 5. Yeah. Okay, I think that's good. We will now, we need to count how many times it flashes. So here we will, so when we do tick, it's going to increment a flash count. So let's just have a private var, or private set var flash count. Starts at 0. And then every time we tick, when we flash, this will set flash count. Flash count plus equals 1. Okay, and then we will see after so many steps, it'll let's see. I don't want to print out every step, so let's just do. We print out the grid, and then we'll have num steps is 100. We'll print after num steps. We'll say 1, 2 num steps for each sim.tick. Then print the grid. And then we'll print flashes sim.flash count. Okay. Cannot convert value of type that to expected type. Okay. Okay, let's run it. That doesn't seem like very many flashes, but it's correct. Okay, let's grab our puzzle input. This is our grid. Let's go over to day 11.input. Let's get rid of this. $16.75. That can't be right. Maybe it is. Okay, part 2. In the example above, okay, it seems like the individual flashes aren't bright enough to navigate. However, you might have a better option. The flashes seem to be synchronizing. In the example above, the first time all octopuses flash simultaneously is in step 195. Wow, okay. If you can calculate the exact moments when the octopuses will all flash simultaneously, you should be able to navigate through the cavern. What is the first step during which all octopuses flash? Maybe there's a way to do maybe there's a way to calculate this without just running it until all values are 0, but let's see. We already have a map function. What if we have an all satisfy function that takes the value of the grid at each row and returns a bool? And then I can iterate over every single one. So this would be basically data.allSatisfy. That gives me the row. And then I'd say row.allSatisfy. All satisfy. And that would take in this function here. And this whole thing would return a bool. Okay, so I want to go back over to test and do 193 steps and just see that we get all zeros. No. Oh, it's 195. Man, my window movement is not working anymore. Or at least Control K is not working anymore. Okay. Should be working. Maybe it's because of the dash thing. But if that was happening, it would be opening dash. That's Shift K. Yeah, I'm not quite sure what's happening there. Something I've recently added is messing with my window movement. I'll have to fix that later. Okay, so that guy, let's run. We get all zeros. Okay, so we are correct on that. Here, we're going to say var num steps, max steps. I'm going to put like 10,000. And then we're going to say for step in 1 up to max steps. And then we are going to so steps is going to increment. We're going to have to do sim.tick, and we're going to say if grid sim dot all flashed. So let's do here func all flashed returns a bool. And here we can say grid.all satisfy $0 equals 0. Okay. If all of them flashed, then we will print out after steps, we'll print the grid and the flash count. We've already ticked, and then, yeah, after so many max steps, it needs to be a let. Okay, now we run it, and the 995 steps. Not right. Your answer is too high. Make sure you're using the full input data. Oh, this is because I'm not using my real input. Of course, if I was using... Oh, yeah. Okay. I also have another problem. I never break out of this loop. Right. It's just going to keep running and running and running. But I want to use our live input as well. Okay. Let's build and run. And this time, after 515 steps. Okay, so we have to wait a minute before trying again. So in that minute, I'll enjoy some coffee. Okay, the answer was 515 steps. Okay, we finished day 11. Let's see. So those are all staged. And I don't know what I just did. Let me do that again. Those are all staged. Create a commit. Day 11. Okay. Cool. Any questions about what we went through on the stream, or any questions about the Vim setup or whatever? I do actually want to go through and clean up those warnings. So I'm just going to do that now. But if you have any questions while I'm doing that, let me know. So day 4, confusable with the body of the statements. Day 4, Swift line 60. Okay. Day 4. Trailing closure of this. Okay, yeah. So I think I want to do that to help the compiler out a little bit. Okay, that's good. I think that's it for this file. Leader, nope, not that. Leader ST. Check that file. Okay, let's go to day 7. And immutable cost was never used. Okay, that's cool. We don't even need to iterate over that anymore. Okay, let's go over here and run the build again. I need to figure out what the best way is to clean. Oops. RMRF Swift build. Swift build clean. Swift build dash clean. Didn't I just do that? Has been replaced with Swift package clean. Okay. Swift package clean. Then build. Okay, day 9 has a low point height that's not used. Where was that? Line 60, right here. This was not used, but SourceKit LSP is not helping me at all in this for some reason. Low point. Oh, there it goes. Neither of those were used. It's kind of frustrating because some of these things were used in part 1, but not part 2. And, you know, I didn't know how to structure, how to solve these puzzles because this is my first advent of code. Okay. Yeah, I think that one is probably done. Let's go back over here to this guy. Swift package clean and Swift build. Let's do that. No more warnings? I guess not. All right. So let's commit all this stuff. What did I do? Ah, I pushed minus on accident. Okay, go back. I'm not quite sure what minus does here. Oh, it's probably letting me browse the repo or whatever. If you do Shift 0 or the parentheses, it'll jump down to this, and I can select them all, hit dash or minus or whatever. That'll stage all of them. Then I can do CC to create commit. Clean up warnings. Okay. Then we can do G push. Git push. Okay. All right. The code is up on the GitHub repo. Thanks for those who stuck around and watched the stream. And I am posting these to YouTube, but on a slower schedule, so they'll show up when they show up. I'm not quite sure how hard day 11 is or day 12 is. Yeah, I'll probably have to go start looking at this and see what to do. I've heard that these are getting considerably harder, and I don't have a ton of time to work on them, so I'm not sure if I will stream these, but yeah, we'll see. All right, I hope everybody has a great day. We'll see you next time.